Hello everyone, this is Sakshi and I welcome you all to my EduTech platform Way to Learn. So today I'm going to solve some of the problems from classical mechanics. And today's topic is Poisson brackets. So my first topic was on stability analysis, second was small oscillations, and third one is Poisson brackets. So before I start, let us go for the quote. Success is not final, failure is not fatal. It is the courage to continue that counts. So, if you have courage to start, then you're going to do it. So, let us start with our Poisson brackets. So, let me say that I have two quantities, F and G. These both quantities depend on generalized coordinate and generalized momentum and time t. So, how do I find the Poisson brackets for these? So, this is the general formula to find the Poisson bracket. So, this summation represents for different values of q and different values of p. So if q has different values such as q1, q2, q3 and p has p1, p2, p3, you'll have to find the Poisson brackets for each term and then sum it up. So the other method to find the Poisson bracket is the Jacobian determinant. It is nothing but the first row consists of our first quantity and the partial differential first quantity with the partial differentiation of q and partial differentiation with respect to p. Similarly, the second quantity forms the second row with the partial differentiation of q and the partial differentiation with respect to p. So this is just a simple formula and let us go to a problem. So our problem says to find the Poisson bracket of mod of r and mod of p. So the mod of r is we know that how to write mod of r. It is root over x squared plus y squared plus z squared. And mod of p is root over px squared plus py squared plus pz squared. So I'm just substituting instead of mod of r as this and mod of p as this. And I assume this term to be a and this term to be b. So my a has three terms x, y and z. And b has px, py, pz. So now I have to write the Poisson brackets for each terms that is x, px, y, py and z, pz. So I have to write the Poisson brackets for all these three and then sum all these three. So I have written in the Poisson bracket formula. So now we have to simplify it. So if you see in every bracket, the last term goes to 0. So this is dou a by dou px. My a doesn't have any px and my b doesn't have any x. So this term goes to 0. Similarly, in all the brackets, the last term goes to 0. So these are r and p, okay. So I'm just simplifying. I have only the first term from all the brackets. I have to just simplify those. So I have just substituted, instead of a I have substituted my a term and instead of b I have substituted my b term. So on partial differentiation I get the following. So if you have any doubt in partial differentiation, comment me, I will let you know. So this is my partial differentiation. On differentiating this, I differentiate this term first and then I differentiate x term. Similarly everywhere I differentiate this term first and then I differentiate with respect to whatever it is, whatever quantity is over here. So now after differentiation, you can see that this term is similar to 1 by mod r and this term is similar to 1 by mod p. So and 2 everywhere get cancelled. So here x is present and here px is present and everywhere it's y, py, z, pz. So now my next step is, so on writing those terms as mod r and mod p, I get x by mod r into px by mod p, y by mod r into py by mod p, and z by mod r into pz by mod p. So on simplifying this, I have this term. Now, I can write this x, px, y, pz, y, py, and z, pz as their vector forms because I know that dot product of I into I will give me 1. So xi into dot product of pxi will be xpx. So on doing this, I get this term. So I have just expanded this into their vector form. So now I know that this is my r vector and this is my p vector. So I have written in terms of r vector and p vector. Now we know that r vector by mod of r is r cap and p vector by mod of p is p cap. Hence the Poisson bracket has the answer as rcap.pcap. I hope you understand this question. So if you get this, then this is your homework. So, and also next I'm going to give you the solutions of my previous homework problems. So this was my first homework problem, which was from stability analysis. So here I have my potential and I have to find the frequency of small oscillations. So how do we find? We have the potential, we have to find the equilibrium points by using this formula dou v by dou x, which is equal to 0. So I have found the equilibrium points as this. And the second step is to find if they are stable or unstable. So we have to take the second derivative, and I have taken this and found the stable point. And the third step is to substitute in the angular frequency formula. So this is my frequency of oscillation, which is option B. So now the second homework question was from small oscillation. Here I have the Lagrangian, and I am asked to find the normal frequencies. So you can see the word normal. So we are going to use our secular equation. So I have this Lagrangian and I'm separating this as t and v. I know that L is equal to t minus v. So this is my t and this is my v. So I'm writing it in the exact form. So which is t is equal to half m x1 dot square plus half m x2 dot square. And here v, if you see that we have k into x1 x2. We don't have x1 square x2 square terms, but we have x1 x2 terms. So now we have to do like half k into, I'm just splitting this x1 x2 as half x1 x2 plus half x2 x1. So here x1 x2 and x2 x1 are the same. So if you add half plus half, it will give you 1, which is exactly this. So I have just splitted this and written like this. So this is my v. I have written like this, so I can use it in my matrix form. So my step 2 is to write t and v in their matrix form. So t here is half m0 0m and v here is half 0 because we don't have x1 square and x2 square terms. We have only x1 x2 and x2 x1 terms. So now v here is k by 2 0 k by 2 k by 2 and 0. So what is my step 3? To use the secular equation. So I am substituting my v and t in my secular equation. So this is my secular equation, and now if I simplify this, I get this term. I have to directly take the determinant of this one. So this is m omega squared the whole square minus k by 2 the whole square. So if you simplify this, you get omega square is equal to root over k square by 4m square. So on further simplification, you get omega is equal to k by 2m the whole power half, which is option D. So I hope this solution helps you. So now you can solve even more better. So keep watching my videos. I'll be uploading more problems and more solutions too. So stay tuned. Thank you. Do not forget to like my videos, share my videos, subscribe my channel, and also do not forget to hit the bell. Only when you hit the bell, you're going to get my notifications. So thank you. See you tomorrow. Ta-da!